Hello everyone, this is the second assignment of georeferencing and digitizing. Here are all the instructions for the lab assignment 2. We will just follow these instructions and georeference some images and digitize the California Trail in 2 counties. So do give these instructions a thorough read and follow the instructions, and you just have to submit the deliverables on time. So first create the project according to the previous instructions, and we will need a topographic map. We will search here for the topographic map, and here is the map. We will just drag it and drop it here. We will georeference the images according to this topographic map. So it will help us a lot to georeference the first images. So the data of this lab assignment has already been uploaded. You will find that in Canvas, in files, and in the lab instruction 2. So here you can see we have several images. I have taken just one of them, which is the SLC North image. We can see that it does not have any spatial reference or coordinate system, so we have to project this image. We can see that the spatial reference of this map is USGS 984, so it is not even in the projected coordinate system. So we have to project both of these, the topographic map and the SLC North image as well. We have to convert them into projected coordinate system. So we will use this project tool for the topographic map, and we will project it into its corresponding projected coordinate system, which is the NAD 983 UTM zone 12 north. So this is the projected coordinate system for this which corresponds to this study area of ours in Salt Lake City. So we will project the topographic map with this coordinate system, and we will also project the Salt Lake City North image with the project raster tool, because this is a raster image. So whenever you see the input coordinate system as unknown, you will just put the input coordinate system as WGS 984. So remember that, otherwise it will show an error. We want the output coordinate system to be the same as the coordinate system we used to project the topographic map. So remember, whichever has unknown, we will just input the WGS 984, the geographic coordinate system of WGS 984 from here. And you can give any names to the projected raster that you are creating now. Okay, so our projection is now done. Now we will start georeferencing. We have to select that image that we want to georeference, then go to the imagery, then click on georeference. Now let's zoom into our study area. Let's zoom into Salt Lake City North in the topographic map, and we want our image to be georeferenced or be placed in here because the image corresponds to this area. So currently the image does not has any spatial reference. The image does not has any special attributes, so we are trying to give some special attributes to this image. So we're just taking this image and putting into its perfect location. So this is known as georeferencing. We will select this thing and we need to click set SRS if you see that the fit to display section is unavailable. If you just click on set SRS, the fit to display icon will appear available. Just you have to just click on that and your image will appear wherever you want to make it appear. So we know that we have to georeference it here. So these are the corresponding points. So this point has to be in the intersecting point of this. Yes, this point has to be in that intersecting point of the topographic map. So we are clicking on our image and clicking onto the point of the topographic map where we want our point to be located now. Now if you click on apply, it will be applied and you can see that our image has been moved towards one of its correct place. So we need more points to add here to fit this image correctly into its location in the map. Okay, so we are adding another control point here. This intersection has to be here. So after clicking apply, it will be applied. If you click auto apply, then whenever you select that target point, it will be automatically placed in here. But for now we are not using the auto apply part. We can see that it has already been placed correctly, but we can see that there is a very minor correction needed now. So even if you don't want to do this thing, it's okay, but it makes it more correct. Okay, now we can see that it has been placed correctly. The image is now placed in its actual location. So we have now georeferenced this image, and it is best to take the points from different parts of an image. Now we will save this georeferenced image. So if we now remove this image and try to add this image again, we will see that this image will be automatically placed into its correct location, because now we have georeferenced this image. In my YouTube channel there is also some other videos on georeferencing. You can also follow those to georeference images of different locations. You can follow those as well. Okay, now we have to georeference the other 6 images, just like this one. I have done one for you, which is for the Salt Lake City North. I have georeferenced it for you, and I'm showing you another example for another image. I will just georeference it in the same way, and these are quite easier to be georeferenced because we have the intersecting grid lines very visible in these images, but you will face some problems digitizing some images which does not have this grid lines. Rather, those are very raw images or satellite images, so those are quite much tough to be georeferenced, because you have to look for particular attributes like the roads, rivers, and other land covers to georeference those. So I have done I am done with georeferencing all the 7 images in the same way. Now we have to create a feature. you can just do it in the following way. And I think you have seen that we need to add two fields here in the feature class, the line, the polyline that we are trying to digitize for the California Trail. We have to add two fields here. One is section and another one is comments, and you have to give it the same coordinate system as well that you have previously provided to the images. So do also follow the instructions in the PDF file for lab assignment too, so that you can easily get the information. From here you have to go to the editing and then create features, so that now you can digitize your California trail. You can use any of these symbologies for the line you will be going to draw. Now from create features you will just click on the polyline again, which is already have been in default. So you will be digitizing this dark thick red color. I am doing it randomly. I'm not doing it so much perfectly, but your one has to be perfect. So, and also while digitizing, if you take any wrong points while digitizing the line, you can just click on Ctrl Z to undo your step and try to digitize the lines that follow correctly. If it has any kind of intersections, you can just double click on digitizing and end your digitizing, then start again from the vertex or the edge of one line to digitize any other subsections of this line. So remember, you have to do it perfectly, which in my case I am not taking much time to do it, because it's your assignment for now, not from me. I'm just trying to help you out of how you can do it perfectly. Now here is another part of it, so you can also digitize it. Remember to click on the snapping tool that you will find in the edit section. It will help you to show that to connect the edges or the vertexes of other points, of other lines. Like whenever I go here, you can see that it is showing me that this is an edge of the California Trail. So do remember to keep this snapping tool clicked. So in my case, I have already clicked the snapping tool, so it is quite easier for me to digitize this trail perfectly and try to match all the edges that you will see. I mean, all these lines, even if they are separated, they have to be, even if they have several sections, but they have to be connected to each other. You can also see the instructions that are clearly given in the PDF file of instructions, so that you can correctly follow all the things and submit the deliverables as well. We just have to save the edits from here. So now we are done digitizing the topographic images. Now there are six satellite images, which we also need to georeference first in the same way, and then also digitize the trail that will go over to those satellite images. The images are from the very past, so the projection should be this for the images, but this projection is not available now, so we will also use the earlier projection coordinate system to project these images as well. For the for the input coordinate system, we will still give the WGS 1984, and we will use this up-to-date coordinate system for the satellite imagery as well, the earlier one that we used to digitize the images from the topographic map. In the same way, we will use the georeference tool. Then after and we are doing this after projecting our image actually. So when we are done with the projection, we will do the georeferencing, but this time we don't have grid lines to follow, but we will see several features or roads from here. You can see that this point of the image corresponds with this point of the topographic map. That's why we are trying to add a control point here and give the other control, the target point, to be here. Now you can see that the satellite image has been located in its perfect location. Still we need to add some other points so that it is perfectly suited in its location. For now it's just accurate for that one point, but still we have to add several other points to georeference this image correctly. Okay, now it is quite correct, but still I think it will not match 100% because this image has been originated it originates from very past with a different coordinate system, with a different projected coordinate system, but now we are using another projected coordinate system for this image and for the topographic map as well, so it will not match 100%, but we will try to match it as much as possible with this topographic map. You can also reduce or increase the transparency so that you can view the underlying points of the underlying features of the base map, the topographic map, so that you can correctly georeference. Also now, another thing that you will find the georeferencing different values like the total RMS errors and so many things written in here, so you have to submit those RMS values, the forward, inverse, this as well to me. It will show up while georeferencing each image. So I'm doing another image for your help because first of all I will project this imagery and then I will georeference it in the same way. Actually, georeferencing these images is a bit more complicated because we do not have the grid lines showing up now of these images. Rather, we are following the features of these images and trying to georeference them in accordance with those features that we can see in the topographic maps. So I am doing the same for another imagery for your help. So we can see that this part of this image actually corresponds with the with that part of the earlier image, the Hastings one. So we will just take a control point from this image and put it here, because both of these points should match. This is an image that continues the California Trail. So the red thick line is the continuation of the California Trail, which we still have to digitize after georeferencing this 6 image, and these 6 images are also connected with each other. So I'm just doing 2 of these so to show you the process, and you have to do the rest yourself and also digitize the whole California Trail following all the instructions of the PDF file. So I have found another. You can uncheck this image to view the underlying image of it. Just first of all click on the point of this image, then uncheck it, and after that you can put your target point in the underlying image. Now we can see that it has matched quite perfectly. So the more you take control points in different points, and make sure that the points are far from each other, the control points, so it will become more accurate. Now we can see that it has matched quite perfectly, but not that perfectly. As I said, that the images has a different coordinate system than the topographic map, and also it is quite difficult to match this 100% perfectly, because these does not have any grid lines present here. So we will try our best to match as much as possible and keep the control points as much separated as possible. We will take those control points quite far from each other. And now I think it's quite good, so I'm saving our georeference image. And now I will go to the create features again to continue our California trail. So you first of all have to create the georeference all these 6 images, which will just align with each other in a line, because it is continuing the California Trail. So after completing all those 6 image georeferencing, after completing georeferencing all those 6 images, he will then start to digitize, but I'm doing it for just 2. And also keep in mind that you have to georeference this images pretty well, because I will be able to check the errors in digitizing as well. If I just overlay your trail with my trail, I will simply see that the errors made by you. So be careful while digitizing, and the other 4 images should be digitized by you. I'm just saving these images for now, and this is simply this is all about the assignment. You can still follow the instruction and the deliverables from there. You have to do the 4 others, which will also be following the whole California Trail in the same manner. And do check the instructions from the deliverables, and make sure that you check all this so that you can get all the points for this assignment. Okay, I think it was helpful for you.